Hi, my name is Michał Ambroziewicz. I am a solution architect at NetSprint. We are an online data-driven marketing company, a house of data, if you will. If you want contextual advertising, behavioral targeting, or profiling, you come to us. So today we will talk about Kubernetes. We have started our adventure with Kubernetes about 2 years ago, and now we are running 3 clusters, all of them on bare metal. This talk will be a summary of our experience enclosed in simple do's and don'ts, and then we sum it up with a priority checklist that will hopefully lead you to your first successful cluster deployment. We don't have a lot of time, so let's start. First of all, you need to identify your workloads that you would like to put in your Kubernetes cluster. Your perfect candidates are stateless, horizontally scalable, loosely coupled, and by that I mean HTTP or some kind of message broker in between with clearly defined protocols, and contract-driven. That way, your developers need to have only a basic set of Kubernetes entities understanding. Let's say pods, replica set, deployments, config maps and services, and that's about everything they will need for starters. In other words, if you have stateless microservices, you are good to go. Your next step should be securing assets for your sandbox. Make sure it's as close to the production as possible. Minikube is good for starters, but later on you will need some kind of almost production mirror. Mind also the network environment. If you are trying to run your sandbox in your private infrastructure and then you will deploy production to public data center, that's entirely 2 different things. Your next step should be creating a list of critical procedures, and by that I mean deployment, which should consist of items like creating a new application, deploying it, scaling it, deploying a new version, and so on. Maintenance, and by that I mean creating cluster, scaling it, removing a node for maintenance, reconnecting it again, and so on. And disaster recovery. By that I mean not only being prepared for a node failure, especially a master node failure, those are the worst, but also be prepared with some kind of backup solution. There are solutions in the market that will allow you to back up your entire cluster as YAML files and to put them in a Git repository. So watch out for this kind of solutions, and make sure everyone on your team is trained to follow these procedures. Next, monitoring is essential before you go to the production. You should choose a solution that allows you to monitor your pods and containers resources, like CPU, RAM, and network. That's a bare minimum. We have been using Prometheus. We have tried Telegraph and Influx, but failed to obtain those items from pods and containers. You should also monitor your hardware. Don't be fooled if you run your workloads in the cloud. Still, a virtual machine can drop out and you won't even know it. And you should also monitor your cluster status. You should check whether your cluster is healthy, and you should check whether it is balanced. Make sure every pod has declared requests and limits. That is paramount. If I were to limit this presentation to one single item, this would be this item. Without it, there's nothing that stands between you and over-provisioning. If you write your cluster on the edge and the node fails and you have no limits and requests declared, nodes that were pods that were lost will be recreated on another node, will deplete your resources, will be killed off, recreated on another node, and so on until your cluster fails. So have in mind and make sure everyone on your teams understand this. Next, liveness and health probes. Do not mistake them for the same thing. Make sure everyone on your team understands the difference, and make sure all of your application have them correctly implemented. Metrics and finding limits for CPU and RAM. Don't guess, don't estimate, always check. Here you can see plot for 2 pods. As you can see, one is riding steadily with a ceiling of about 4 GB of RAM. The other one is suspected for a memory leak. Without monitoring, you won't even know, and you will end up in a situation where pods are killed with no apparent reason. Perform load testing for your applications before you deploy them to the production. Even if they have previously been run in different environments, Kubernetes, especially when you run it in a public data center, can introduce you to non-deterministic latencies, network problems, and so on. So be prepared to handle them, and only load tests will tell you if your application is still performing well. Next question is security. I would suggest using role-based access control. Assign each of your team members individual tokens, and the same applies to external processes like continuous integration server and so on. Rotate them accordingly. Limit your SSH access to your cluster to essential personnel only. The others should connect to the cluster through a secured API endpoint. You will also have to train your team to use local kubectl to access that endpoint. Next question is exposing your services. You will have to have a really good reason not to use ingress. It might be hard in the beginning, but you will find that ingress is the way to go. We have been using successfully traffic with Let's Encrypt. Its seamless integration allows us to create secured endpoints automatically. While we're at the automation, consider continuous integration and delivery your first investment. We have been using GitLab pipelines. With them, we can deploy our applications with a single click of a button. Consider separating testing from production. That seems obvious, but has some quirks in it. You could say that it's enough to just label your nodes production and staging or testing or something like that, and you are fine to go. But have in mind that this doesn't provide you any kind of network separation, and still all of your pods talk to the same control plane. So if you, let's say, run a stress test through your staging pods, your production can also be affected. Now for a couple of don'ts. Avoid manual operations on live cluster. Use scripts, use Ansible. We have been using Kubespray for a while, and it works like a charm. Do not use try not to use anything that's not repeatable and you cannot check it in your sandbox first. Kubernetes doesn't imply cloud. We have been running clusters on bare metal from the beginning, well, there were some issues, but it saved us a lot of money. So if you are fine with scalability, like new server within 24 hours, you're good to go with dedicated servers, let's say in Hetzner, like we do. It saved us a lot of money. You might also be fine with on-premise or colocation, and it can still be good for you to benefit from other Kubernetes features. You know the saying about an elephant, how to eat an elephant? Well, the same applies to Kubernetes. Identify and master only the components that are crucial for your deployment. If you start with stateless microservices, you probably don't need distributed storage or persistent sets. In the beginning, you maybe don't even need auto-scaling. Do not use primitive entities, and by that I mean don't create a herd of unmanaged pods instead of creating a deployment, let's say. Next are the network issues. Remember that if you run your Kubernetes cluster within, especially within public data center, you might be introduced to non-deterministic latencies, network problems, and you don't have even rudimentary control over what's going on with the network. So make sure that your application can handle it. Another question is firewall. If you are on-premise or in cloud, you are probably good with standard solutions. But if you're going to the public data center, you should check out beforehand if you can secure your network. Remember that the Kubernetes relies heavily on IP tables, and you might not be able to create your standard firewall as you always do. Don't be afraid of chaos engineering, and by that I mean you might be forced occasionally to kill a node, restart a faulty Docker daemon, restart a kubelet, even to kill off some of healthy pods just to trigger a cluster rebalance. Don't be afraid to do that. Kubernetes should handle that without problem. Do not rely on a single master. That one's obvious, but the other one is not so obvious. Do not use even number of masters. It gives you nothing compared to a scenario when you have one master less. Don't forget about maintenance. Kubernetes, for instance, uses multitude of security certificates. Make sure you rotate them before they expire. You should also address all of the hardware issues when there arise. Don't let them become a bigger problem later. Now, a quick priority checklist. Isolate your components for Kubernetes, Dockerize them, choose your CI/CD solution, and secure your Docker image repository. If you are running in GitLab, you're in luck. They provide you with one for free. Next, create a sandbox and prepare maintenance procedures for maintenance and emergency. Train your teams to follow them. Consider separating staging from production. Prepare monitoring for infrastructure and apps. Perform load tests and tune your requests and limits accordingly. Then you can go live. Good luck, and thank you.